Okay, hello Cloud Gurus and welcome to this lab where we're going to take a look at the Google Compute Engine from the GCP console. Now, as I'm sure you've already noticed throughout this course, it's really important to be familiar with both the command line and the console. The command line is direct and consistent, and it makes it really easy to script things, and this is a critical thing for a cloud engineer. But the GCP console is also very important. It can make many of the choices that you need to make a lot more clear, it's often easier to use, and as we'll see, it often surfaces really valuable information that you might not always think to go and get through the command line. So for this lab, you'll need to head into the GCP console and select the project that we've been using so far to explore the services. Alright, I'll see you in the console. Okay, so here we are in the console, and we've got the Services Exploration Labs project selected. And in the menu on the left, we're going to go to the Compute Engine service. In fact, I may as well pin it now just so that it's easy access. Now, the GCE section of the console is divided up into a lot of different subsections. VM instances, instance groups, instance templates, and so on. But let's start by scrolling to the very bottom and going to Settings. Now here in the settings is where you can set a default region and zone to be automatically selected when you're creating new instances and whatnot. Now please notice the region and zone here are not set, even though we just set a default region and zone through the command line. So what does this information tell you? What's your mental model for how you're setting those default values? The fact that they're not set here should tip you off to the fact that you've been setting the default for the tool. And the settings that you use in the G-Cloud tool are separate from the settings you use here in the console tool. In particular, the place that this information is stored is completely separate from the place where the G-Cloud command stores its configuration information. Moving on, let's check out the metadata section. Now this is a place where we can specify custom project level metadata that shows up in addition to the Google managed project metadata. But the key thing I want to call out is the SSH keys. If you switch to that tab, we'll see here the public key that G-Cloud created automatically for us when we used it to SSH to the instance that we had created on the command line. That key is now registered, so any future instances that get created will automatically know to accept this for login. Now there are more things we can do to control that, but we'll get to that later. We're done with the metadata for now, so let's scroll the subsections up and choose VM instances. So if you compare this to the command line, this is what corresponds to G-Cloud Compute instances. So without further ado, let's start the process of creating one. Now just like in the command line, we have to give each instance a name. So we'll call this one my very happy VM. Now the process of selecting a region and zone is rather easier here than to find the list of these and paste the right one into the command line. Now I'd like the instance that I create to qualify for the free tier, so I'm going to pick a region and zone that are in the United States but not in Northern Virginia. So let's go for Iowa and we'll say US Central 1F. Now the console is already surfacing valuable information such as how much it's going to cost to run this instance, and that'll update if I make different selections of either machine type or region. Now I'll just put this back to Iowa, US Central 1F. But since we're looking for free tier, we want to choose the F1 micro machine type. And again, quite helpfully, it tells us not only how much that costs per month, but also that this does qualify for the free tier. Now before we move on, I want to point out that there are quite a few different machine types in this list. At the bottom, the high CPU machine types have the minimum amount of memory that you can use with that number of CPUs. And the high mem machine types are the opposite, where they have the maximum amount of memory. The standard types are somewhere in between, where they're supposed to be a decent blend, but one of the nice things about Compute Engine is that you're not restricted to this list of machine types. You can just hit this Customize button, and then drag the slider however you want. Whatever you select, that's what you'll pay for. Now you can play around with this to get a feel for the different settings, but one of the interesting things about this is if you make a custom configuration that matches one of Google's known machine types, it'll just automatically change it into that for you. In any case, This is also where you can set the CPU platform and attach GPUs and stuff like that, but we're just going to leave it as an F1 micro for now. Now, when we're creating an instance, we can ask Google to deploy a container image for us automatically to it, but if you're deploying containers, you should probably consider using GKE instead. Now, the boot disk is another important choice, and this is where we choose the operating system. The default image is Debian 9, but if we hit this Change button, we see that we have lots of options. All sorts of Linux-based ones, Windows Server, application images that also include things like SQL Server, and if we had created any of our own custom images yet, we would see them in this list. You can also choose to boot from a disk snapshot or an existing persistent disk in this particular zone, but for now we're just going to cancel out of this and leave it set to Debian 9. Moving down a little bit, we get to the Identity and API Access section, and here's where we see the default service account that we used to connect to Google Cloud Services from the VM that we created on the command line. There's a default service account for Compute Engine, but we can also make additional service accounts so that we can scope the capabilities to whatever we want, or we could say no service account so that it doesn't have any automatic access to Google services. For now, we'll leave the default service account selected, but an interesting and important thing to understand is that even when we've given access to a particular service account, these access scopes restrict what you can do with it. By default, you only get read access to Google Cloud Storage, and you don't actually get access to Google Compute Engine, which is why we were unable to terminate the instance that we were using when we shelled into it. If you want, you can set access on a service-by-service basis, but for this lab, let's just set Allow Full Access to All Cloud APIs so that this machine is unrestricted in how it can use this service account. Here we have some settings that we can set about firewalls and allowing ingress to this particular instance, and then we have additional customization options for management, security, disks, networking, and stuff like that. But for now, let's just leave it at that and hit Create. This will take a little bit of time, just like it does through the command line, so I'll fast forward this section. If you're following along with the lab, you can just hit pause now until it finishes. Alright, now that it's finished, we can take a look at the notification here, and it says, yes, it did indeed create it. And if we click on the VM in the list, we get a lot more information about it. Now, if we click on the Edit button at the top, we see that there are a lot of different things that we can change about this particular machine, but a number of them that we can't. The name is not something that we can change, and neither is the zone, but it calls out that we could change the machine type if we stopped the instance first. Because I didn't expand the advanced settings when we were creating this machine, we didn't wind up setting a label, so we can set that now. Maybe setting function to learning, and something like creation mode to console. Here again, we see options for things like allowing HTTP traffic, which would be port 80, or HTTPS traffic, which would be port 443. But these are really just shortcuts for things that you could accomplish through network tags or other custom network configuration. Moving down, we see deletion protection, and the sole purpose of this is to stop you from accidentally deleting machines that you want to keep around. This can have its place, but really, you'd rather set things up so that people are restricted through IAM from being able to delete instances that you care about. Honestly though, this setting seems to be the opposite of the way that you should be using instances. This is about protecting one special machine, but best practice says that you should treat any instance as disposable. Now we'll cover that more in a future lecture, but you can already see here from this Delete Boot Disk When Instance is Deleted checkbox that the default behavior is not to be preserving these instances. You start them up, they do some stuff, they go away. Going away shouldn't be a problem because the doing some stuff part should always be writing everything that matters somewhere else. Now if you want to, you can attach additional persistent disks to machines, and that could be a place where you store stuff. But that way of doing things doesn't play as nicely with autoscaling, so you often want to use a separate service to store the data instead. Now there are some additional options here about preemptibility, SSH keys, metadata, and stuff like that, but I want to show you those options through the Creation UI instead. So let's scroll to the bottom, hit Save, dismiss the notification, and hit the Create Similar button at the top of the VM details. Now this very conveniently pre-populates the information in the Create wizard with the information from the instance we were looking at. So we're already set to US Central 1F with an F1 micro machine type. Now at the moment it says that this machine is going to cost $428 per month, and that breaks down to $555 for the machine itself, 40 cents for the persistent disk, and then a sustained use discount that reduces the cost because this is a monthly estimate. But if we scroll down to the bottom, expand the Management Security Disks Networking Sole Tenancy, and scroll to the bottom of this Management tab, here's where we could say that we did want it to be a preemptible instance. Now before I change this option about preemptibility, notice that the default option for automatic restart is on, and the default option for host maintenance is to migrate the VM. But if I change the machine to be preemptible, now first of all, that changes the cost in that the base cost is now only $256 per month, but because it's preemptible, there's no sustained use discount. You've already gotten the discount by having it be preemptible. But back down at the bottom, you may have noticed that when I set it to be a preemptible instance, it disables these options, sets the automatic restart to off, and says that on host maintenance it will terminate instead. So what are all these about and how do they relate? Well, setting a machine to be preemptible is saying to Google, I don't really care how long this thing runs, I'll take care of whatever happens after that. When a machine is set to not be preemptible, Google will do what it can to try to keep that machine running. If some problem happens, like maybe one of the racks in one of the data centers just dies all of a sudden, then Google can automatically restart it on another rack for you. And if Google knows that they're going to need to get all of the machines off of a particular host, like maybe when they need to update the hypervisor or something, then they can set things up to be live migrating that machine from one host to another. It's quite impressive actually, and you'll almost definitely not even notice when it happens. Well, in a case like that, a preemptible machine will just go away. But it's more than that too. Even if nothing bad happens, preemptible instances will get killed off after 24 hours. Or if Google is running low on capacity in their data centers and there are paying customers who are willing to pay the higher non-preemptible price. So you have to be careful when you choose preemptible that your system can handle all of the preemptible instances going away at the same time, even across multiple zones or regions. Alright, let's scroll up a bit to look at the automation and metadata. Now the startup script here is something that will be run automatically whenever that instance starts up, whether for the first time or on a reboot. But really, there's nothing special or magical about this particular startup script. It just winds up being passed to the instance as metadata. It just so happens that the machine images that Google provides are generally all set up to automatically run the startup script passed in at that particular location. Sometimes the startup script you give could be quite involved, installing all sorts of things, grabbing and caching special files from cloud storage, running different services, whatever you want really. But in many other cases, this startup script will simply run a program that will connect to your other configuration management, like Chef or something like that. Now in this advanced settings section, we also have a security tab. And here's where we could override the project level settings about SSH keys and block them from being used and add custom ones just for this instance. You might want to use this if you have special machines that shouldn't be available to most people in the project, or some machines where you want to allow specific access to those machines and not the others. The point is that these are just options for how you can configure things, and how you use them will depend on your specific situation and what you're trying to accomplish. Now for the disks, remember that the default behavior is to delete the boot disk whenever the instance goes away, though you could either add a new one or attach an existing persistent disk that you had created using this UI here. In terms of encryption, it's generally easiest to let Google manage the keys, though you may have some requirements to use the Cloud Key Management service instead and manage the encryption through that. If possible though, you should try to avoid having to manage the keys yourself outside of Google, because that'll definitely create hassles. For now we're going to skip the other tabs and cancel this and go back to our list of instances. Now at this point, if we wanted, we could definitely start the Cloud Shell up and then connect to this machine in the same way we connected to the one in the command line lab. But we don't even need to do that really. We can just click this button to connect directly to that particular machine. And there we go, we're in. So like before, we can take a look around, running whoami and hostname. But for now, I just want to do a gsutil ls to see that we still have automatic access to that. And we can list the instances. And again, try to delete the instance that we're actually using right now. Yes, we did mean this zone. And yes, we do realize the disk will be deleted. Now this looks like it's taking a while, but if we switch back to the list of VM instances and refresh the list, we see that it's gone. We successfully deleted that particular instance from inside of it, and that's entirely due to the fact that we changed the scopes to allow access to Google Compute Engine through that service account. Now the next thing I want to do here is to look at the activity. Now when we drop down the list of notifications, we see that it's a bit out of date, but if we go to the bottom and press See All Activities and give it a little bit of time to load, then we'll see all the actions that happened. Now we see here that almost all of the logged activities that we've been doing have been happening as our user account. But these last two activities to delete the VM were performed by the service account that was used by the Compute Engine instance. Now this is a really important thing, and I need you to make sure you understand this. So if you're having any trouble with it, please rewatch this video, do the lab again, look into the documentation, and maybe post a question about it on our forum. And the last thing I want to do here, if we go to the menu, go to Compute, look at Metadata, and then switch to the SSH Keys tab, we'll see two new SSH keys that were added as a part of the connection from the console to the instance. Do you remember how when we ran gcloud compute SSH, it generated a private and public key pair for us? It put the public key in this project metadata spot, and it stored the private key on the file system that was running gcloud, which happened to be Cloud Shell in our case. Well, that private key isn't accessible to this console, and the console does this a different way, using temporary keys that it generates instead. It does still register the public key in this same place, but because of this expires on tag, Google will automatically remove these in a short while. They last long enough for us to make the connection to the instance, but not long enough for them to become an issue of someone stealing these credentials and using them to mount an attack. Well, alright, I hope that this has opened your eyes to many of the options that you have available to you in Google Compute Engine. Like always, if you have any questions for me, please let me know. If not, please feel free to move on to the next lecture. Thank you.